So thanks everyone as well for joining this session. So as Devin said, my name is Antje. I work as a developer advocate for AI and machine learning at AWS. And I want to show you in the next 30 minutes how you can put your machine learning on autopilot. So let's have a look. And just a quick note up front, I'm also co-authoring a book right now, an upcoming O'Reilly book, Data Science on AWS, together with a colleague of mine, Chris Freckley, which a couple of you might know. So he's also giving a talk today at the conference about multi-arm bandit model. So super exciting. Check that out. All right, so for this talk, what I'm going to do is I'm going to quickly introduce the traditional machine learning workflow to kind of show you how much work it actually is to build a model from scratch, to prepare the data, to train the model. And I'm going to use a pre-trained BERT model. So we're going to see an NLP use case and all of the work that goes into fine-tuning such a model. And then in the second part, I'm going to show you how automated machine learning can actually help in automating a couple of those steps and really make our life a little bit easier. And both parts come with a demo, so we're not seeing too many slides here, and also see how machine learning and automated machine learning work in action. All right, so let's get started. So I assume some of you already work with machine learning projects, so you should be familiar with that workflow. Before you even start developing your model, you have to do a lot of data preparation, right? So you're getting some data and you're going to analyze the data. You're going to check if the quality is okay, if there's any missing values, etc. And then you need to transform the data, right? Do feature engineering to fit the data to the machine learning algorithm you're about to use, to maybe combine a couple of data columns to features, etc. You validate that the data is correct, and then you create a training data set. Once you've done the data preparation, you can then start with a model development. So you develop some training code, you pick a couple of algorithms. Maybe you want to do some classification. So you're going to choose maybe an XGBoost algorithm. And then you're starting to prototype, right? So you develop the code, you test the model, you validate the performance, the accuracy, and keep iterating, right, over and over until you find a really good performing combination of model parameters, algorithm together with your training data. And once you have that, you can then what I call train at scale. And this is where you really want to use all of your training data available. And you probably want to implement some distributed training to speed up the process, etc. And then once you have your trained model, you can then deploy it into a production environment and start serving predictions to your applications. And even then, you still have to keep monitoring your models and log the outputs to see if there's any drift happening, if your model maybe decreases in performance with the live data. And this is pretty much always the case. So you want to have a really close look at how the models are performing. And then when new data arrives, maybe start a retraining and create a new model. All right, so a lot of work for the machine learning engineers and data scientists. So let's have a quick look into the data prep and the model prototyping phase, because those are really the steps where automated machine learning can help you with. So looking at this first stage around the data preparation, I briefly mentioned it. So first of all, you're going to analyze your data, right? So you'll calculate statistics, such as missing entries, calculate quantiles, check if the data is skewed in any way, and also check the correlation of the data with the target attribute you want to predict, right? And you might even dismiss a couple of data points, columns, features, because they are not correlated with the job you want to do with predicting a specific target. You also need to define the problem, right? Is it a regression problem? Is it a classification problem? What is it? What do you want to do with this data set? And then you're choosing the algorithm, right? For example, for classification, XGBoost is a very popular algorithm, but there's many more. So depending on the problem and the data, you have to pick and choose an algorithm or a few algorithms, test the different performance across, and then keep iterating. And also for the data set itself, you need to kind of identify the schema, right? Type of the content, is it numeric, categorical, is it natural language, right? If you process data, it's text data, it's completely different from processing numeric values. So, and we're going to see this as we're fine-tuning our BERT model here in a little bit. And then finally, you have to transform the data, also known as doing the feature engineering, where you're really kind of transforming the data into the inputs that are optimized for your algorithm. So for example, for the natural language model, we're going to ingest raw text, but we need to transform this in either word vectors or embeddings, which the model can understand. All right, so after the data prep, we then prototype our model. And I kind of split this into two phases, as you can see here on the top. So the first phase is really the prototyping, and this is where you experiment, right? Normally within a notebook environment, you just have maybe a smaller subset of your data, and you choose a set of hyperparameters, which are the model parameters, and you evaluate the model, keep iterating, change parameters, see if the model performance is improving until you really have a satisfactory model. And then the next step is to productionize or productize the model, right? This is where you really train at scale, and you could leverage GPU instances, GPU environments to accelerate the training over a large data set, and then really kind of harden the model and make it ready to be deployed into the production environment. All right, so this was a little bit of introduction about the traditional, normal, manual machine learning workflow. And let's actually see how this looks like. So I'm going to jump here into an AWS environment. And for those of you working with machine learning, this environment should look familiar. This is a Jupyter Notebook environment. And this is really traditionally where machine learning engineers, data scientists start prototyping, developing models. It could be a local IDE, or it could be a hosted Jupyter environment in the cloud, which I'm using right now here on AWS. Right, so I said we're starting with a manual process. So in this case, first of all, I need a data set. And I'm using the Amazon Customer Reviews data set in this example, which is a public data set you can use for research. And it consists of over 130 million of customer reviews coming from the Amazon.com marketplace. So whenever you go on Amazon.com and you look for a product, you might always check the reviews, right? If other customers rated it with a 5-star, really great product, or maybe a 1-star rating, which is, well, I wasn't really satisfied with this product. So this data set we can use and actually use for NLP use cases. It's really, really nice. And this is exactly what I'm doing here. So we first of all need to analyze kind of the schema. So we can look that up. So we do have a marketplace information in here, customer ID, which is a random identifier, so don't be scared, a review ID, product ID, etc. And what we're really interested in is the actual star rating and the review text, which is called the review body here. So we're going to have a collection of customer reviews for products. And what I want to do is I want to build a model which classifies the reviews into those star ratings from 1 to 5, with 5 being the highest. All right, so first of all, when I'm a machine learning engineer, data scientist, I'm going to analyze and visualize my data, right? So here's a lot of code. You probably write some visualization code as well, and you're checking how the data looks like, right, to better understand your data set. So in this case, I'm running a couple of queries here, for example, calculating average ratings per product category. And here you can see, by the way, the highest rated category by average is gift cards. So with a 4.73 of a star rating. Interesting. And maybe you're asking, what's the lowest rated? And we can also have a look here. It's digital software, actually. All right, so this is just a little bit of the first step. And then you want to maybe analyze your data, right? A little bit more in detail. So you could leverage a couple of tools. I'm using a tool called DQ here. DQ lets you run data quality checks over data sets. And here I'm using it to, for example, check if the review ID is complete in all of my columns here, of all of my rows in the data set. I'm also checking any correlation between total votes and star rating maybe. I'm calculating the mean of star rating, etc. So you're going to do some checks you want to perform on your data set and make sure this is in good shape. All right, let's assume our data is okay. Then the next step is to do feature transformation, feature engineering. And for our model here, what I'm going to do is I'm going to use the ingest data consisting of a star rating, which is my label, and a review text. And this is going to be my raw input training data. And I need to convert the raw text into word embeddings that my pre-trained BERT model expects. And BERT is a very popular architecture in the space of natural language processing. If you're not familiar with, I'm gonna also give you the link to this code repo where you'll find all of the notebooks. And here on top, there's a couple of more links to slides and videos which explain the BERT architecture in more detail. All right, so the feature engineering is to take this raw input data and then convert the text basically into those BERT embeddings. All right, I'm doing all of that. I'm setting up my environment here, reading in the data, adding maybe a little bit more data to see how the model is performing here. And the next step, really the big step, is to write a processing script, right? So I develop my pre-processing script. Here's a simple Python script, which actually pulls in this pre-trained BERT model from a library called Hugging Face. And it's also coming with a tokenizer. And the tokenizer is used to basically split your input raw text into tokens. And then we're going to encode those tokens into those embeddings. So this is really everything you would do as the machine learning engineer here or data scientist, write all of that code and then run the job and basically pre-process your data. Once that is done, you can then start training the model. And what I'm doing here, I'm not training the model from scratch. I'm in a lucky position that in the NLP space, there's a lot of pre-trained model. So I'm using a pre-trained model from the Hugging Face library. And this is already trained on a large corpus of books, etc. So what I need to do is really just fine-tune that to my specific data set. You can think of it like as transfer learning, if that rings a bell. So I'm kind of taking the pre-trained big model and really just adjust it to my specific data set, which are those customer reviews. So in this step, again, I'm doing a lot of steps here. I'm checking where my pre-processed data lives. I'm also probably want to set up some experiment tracking, right? So I'm pulling in here a tool that AWS offers to track my experiments, add the preparation and the training step here, and then just scrolling wildly here. Tune it for the specific environment, set up, for example, distribution strategies, how to read in the data, set hyperparameters, and then at one point, I have my training script. So I'm developing the code to actually run the model training. All right, and then as the next step, I probably also want to tune the model, find the right hyperparameters. And hyperparameters are kind of the model settings. And I need techniques to kind of help me automating this as well, right? I could do it manually, but normally I guess many leverage tools that automate this process here, but still it's yet another step in this manual machine learning workflow. All right, and once all of that is done, I can finally deploy my model into a production environment and integrate the API, for example, into an application to serve predictions. All right, so this was a very fast walkthrough how a machine learning engineer, data scientist would start developing and would perform manual machine learning. And all of those steps can take a lot of time, right? I mean, this is not really done in a single day. This is probably a couple of days effort, really kind of iterating, developing code, checking model performance, etc. All right, so let's see how we can optimize this. So if we're looking back at our overall workflow, the automated machine learning, kicks in exactly here. So AutoML helps me to automate all of those steps, starting from the data analysis up to the training and tuning at scale, and will present you with model candidates, which you can then take and deploy into a production environment. So in short, automated machine learning aims at automating the process of building a model. And in particular, it helps you to identify the problem, right? It decides whether it's regression, whether it's classification. It will pick an algorithm for you. It will pre-process the data, and it will also help you in finding the right hyperparameters. And you might ask yourself, well, I am an expert machine learning engineer. Can I still leverage AutoML, or does it make sense for me, right? So what are the scenarios to use AutoML? And you can really use it whether you're starting in your career and you don't have much ML experience at all. This is kind of the easy entry point here, where you think, well, I'm just using tools that provide me with automated machine learning. And maybe you're coming more from a software developer background, or maybe from a business background. And then, maybe your team has the experts in data science, which then focus on the hard problems. But even if you're an expert yourself, you can use AutoML to kind of give you a baseline for, many of the use cases that are maybe simple to solve, but there's just many of them, so you can help get some help with AutoML, and then focus yourself on maybe new problems where you really need kind of the human experience. And also just, help you automate a lot of that work, for example, the data cleaning, feature engineering steps, etc. And then you as the expert can apply your domain knowledge and maybe do some advanced error analysis. All right, another important point is the transparency and control. So some of the automated machine learning solutions only give you the best model, right? So you're putting in data and you're getting a model. But this is really making it hard to understand what's happening, right? How to reproduce the environment and this model training step if the only thing you get is the final trained model. So you really want to check that there's a little bit more transparency, and not only the best model return, but you also maybe see how the candidates got defined, and even maybe get the source code of how the feature engineering was executed and what parameters got set to actually tune the models and then come to that last best model candidate. So it really helps you to understand how the model was built, helps you to explain the model, and then you also see how you can tweak it maybe for extra performance. All right, so what I'm going to show you in the next demo here is how you can leverage AutoML with a service called Amazon SageMaker. And here's just a rough overview of all of the AWS ML Stack. And it's really comprising of 3 different layers. On the top, you see AI services, which are ready to use. So those are really simple API calls into a fully managed service to, for example, get speech recognition, image recognition, text translation, etc. So those you can really embed in your applications without any machine learning experience. And on the bottom, there is, the choice of different frameworks, infrastructure, instance types for the experts that want to customize everything themselves. But the sweet spot is really kind of in the middle here with a service called Amazon SageMaker, which gives you a fully managed platform to build, train, and deploy your machine learning models. And Autopilot is one part of the SageMaker family of services and functionalities here. So the service gives you really everything from the hosted notebooks to the experiment tracking capabilities, data pre-processing, training, tuning, debugging, up to the model hosting. So we're going to see one specific service here called Autopilot, which runs automated machine learning. And the good news about Autopilot is that it covers all of those steps that I mentioned. It will identify the problem we're trying to solve. It will select the right algorithm. It will perform the feature engineering. And it also shows you the code that it generates to do that. And it runs hyperparameter tuning. It's fully transparent, and we're going to see that it's also generating 2 additional Jupyter notebooks for you to use. So it's documenting all of the steps that it recognizes, all of the findings, the insights during this process, and generates 2 Jupyter notebooks, which you can then grab and use and tweak and develop further if you like. And as of now, supporting regression and classification. All right, I'm probably skipping over this, but just want to highlight, here's a really, really great white paper published by the Amazon Science team, which goes into a lot of details how Autopilot works and how the different steps actually execute and what's happening there in the background. On a high level, what we're going to do is we're going to point Autopilot to our data set, and it will start looking at the data, splitting the data into training validation sets. It will generate the code needed to do feature engineering based on an algorithm it picked, and then it applies the code, it transforms the data, and it will also train and tune the model and then present you at the end with a ranking of the best performing model candidates. So really, really cool. All right, and those are the steps that I just mentioned. So we're going to start with pointing it to a data set, which is in S3. We're going to configure our AutoML job with the location of the data and completion criteria. We're going to launch the job, and then we're going to see the result, the candidate definitions and those notebooks. And we can deploy the best candidate as an endpoint to serve predictions. All right, but better seen in a demo. So let me switch back here to my environment. And this time, I'm jumping into the SageMaker Studio IDE, which is also part of the SageMaker service. And here I'm now operating in this nice IDE. And I do have here my traditional environment. So I can see here notebooks, which I pull down, etc. And I also have here on the left an icon for running experiments. And this will actually launch my Autopilot job. So what I'm going to do here is I'm going to click on Create Experiment. And I'm starting by giving it a name. So let's call this Reviews 04. And you need to point it to your data. So here you can see it needs to be in a 3 bucket. So let's do find a 3 bucket. And I'm going to take here one of my buckets. I'm in US East. And you need to point it to your data set. And my data set is somewhere here in the data bucket. And you can see here it's the different categories, the camera, digital software, shoes from the Amazon.com marketplace. So let's use maybe the camera. And this one contains a bunch of reviews from the category of cameras on the marketplace. All right, it's a CSV file. So it contains the star rating and the review text. And the target is the column we want to predict. So in this case, I want to predict the star rating. And where to store the results. So I'm going to pick another bucket here. And you can give it, for example, AutoML results. And this is going to be the bucket where it basically saves the results. And you can tell it actually which problem type to solve, whether it's binary classification, regression, multi-class, or you can keep it with auto, and then Autopilot will figure it out itself. So let's try this. And then you can also run a complete experiment or really just generate insights. We want to run the complete thing. And you can also specify execution roles which give permissions, obviously. You can encrypt the data. You can put it in your own network environment. And you can also specify the runtime, so you can time limit the jobs. The important one here is the maximum candidates, and this is the maximum list of model candidates to return. So let's just say 3 candidates. You can go up to 250 if you like. All right, and I click on Create Experiment, and this is it. So this starts my Autopilot job in the background, and you can see here, it will approximately run for 20 minutes. It's starting with the pre-processing of the data, it looks at the algorithms and then also generates candidates. And at the end, it will tune and then present us with the best performing candidate. All right, so because we don't have 20 more minutes to wait for the results, I've actually run this job just before the session so we can see how the results look. So I do have my reviews 03 experiment here, so I can describe the job. And in this case, I actually said, give me 5 model candidates, right? So I do see here my candidates, and I can sort here by the objective, which is the accuracy. And I can see here in this just 20 minutes run, I already increased the accuracy from 27 up to 53%. And I can further increase by giving a larger data set, adding more data, and letting it run for a little longer. So I was kind of keeping it short here for the demo. But you can see here the different jobs, and you can also get in more details about the individual jobs. So you can go in here and you can see some nice dashboards. Here is how the objective metric, the accuracy, went up. And you can see the metrics that are being calculated and the parameters used, right? So a lot of insights already, but the really cool thing is the additional outputs that Autopilot generates. And I've downloaded those here. So I'm going to open those 2 notebooks, which the job actually generates. So the first one is a data exploration notebook. And this is a fully functional Jupyter notebook, right, which you can run and execute. So in here, Autopilot describes the data. So you can see the input was star rating and the review text. And it says 2 input columns here, and it identifies missing values, for example. It calculates statistics, the mean, the average, etc. So it gives you already a good insight in the data. And if you have more columns, definitely more interesting than with the 2 that I have right now. And then even better is the second notebook, which shows you the complete candidate definitions. So this notebook, and you can see there's a lot of text, so it annotates the notebooks with a lot of normal text here, so you can read and understand what's happening. And you can see that Autopilot identified this problem as a multi-class classification, and also chose the accuracy to maximize as the objective metric. And if you scroll down, it documents the technical setup, the Python versions, SDK versions. It gives you the code to download all of those artifacts, the results, and the code to set up and reproduce the environment. And it also shows you those generated model candidates. So you can see here, in this case, I said, give me 5 options. And the DPP0 is the data preprocessing pipeline. This is option 1. And it shows XGBoost as an algorithm. And then it also gives you strategies to how to do the feature engineering. And it does that here with all of the model candidates, basically. And you can scroll down here, the code goes on. And at the very end, it shows you how to do the tuning hyperparameters and also how to deploy the best model into a production environment. And just a quick note here, it also gives you all of the code, the feature engineering. So I'm just going to open up here this dpp0.py. And this is my Python code here that shows you how the feature engineering was applied to my data set. In this case, it used a TF-IDF to perform and switch the raw text into word vectors. So really cool. And this is how easy you can start an Autopilot job with the help of SageMaker Autopilot here. All right, so you can also then choose to deploy the best candidate in production. And this is really as easy as just clicking right on the best performing jobs. If I choose the job here, I can here click deploy model, and this will help you to deploy this model into an environment. All right, so this was a quick sneak into how to perform AutoML. And here are a couple of links for you if you want to get started, the link to our book. But also probably more important for you is the GitHub repo, where you can find all of the manual machine learning code, which I showed, and how to get started building machine learning projects on AWS. All right, and with that, thank you very much. And I think we do have a couple of more minutes if there's any questions.